All right, let's look at number 19. 7x squared is equal to negative 14x plus 6. So in this case, we don't have to move the constant. We need to move our linear term. Sorry, totally blanked on what that's called there. Okay, so add the 14x so that it's on the same side. 7x squared plus 14x is equal to 6. Okay, so it would be great if we could divide all those by 2, but 7 is not divisible by 2, so we can't reduce it at all. Let's proceed with completing the square. What did we do when our a was not 1? We factor that number out, so we've got x squared plus 2x is equal to 6. Let's complete the square. So we divide 2 by 2, we get 1. 1 squared is equal to 1. So we add 1 inside of our parentheses, but you don't automatically add 1 to the other side. Because 1 is inside of our parentheses, what's in front of our parentheses? 7. So really, we added 7 to the left side. 1 times 7 is 7, so we have to add 7 to the other side. So there's a little difference. If you have to factor out that leading coefficient before you add that number to the right side, you got to multiply by, bless you, what you factored out. Okay, or you're going to get the wrong answer. Okay, then we proceed like we normally do. Okay, that's 7 times x plus 1 squared is equal to 13. Now, before we can take the square root, we got to do something with that 7. So we've got to divide by 7 first. Here's where the quadratic formula would be better to use on this than completing the square, because it's a little yucky at this point. So we take the square root of both sides. We get x plus 1 is equal to the plus or minus. Man, I wish those were perfect squares, but they're not. So I gotta leave them like that. Let's move our 1 to the other side. Now, I could go through the process of showing y'all how to combine those, but I'm not going to worry about it. What I am going to show you is how to compare and make sure that your answer matches the answer on the answer key. Okay? I don't really like doing this as a math teacher, but it would take a long time to explain that one mathematically. So, you type it in. -1 plus the square root of 13 over 7. 13 over 7 is under the square root, so it goes inside the parentheses there. Okay, you press enter, so you get the decimal value of it. Let's see here, where's my answer key? Here it is. Obviously, that answer to number 19 looks very different from what we have on our paper right now. Okay, it's because they have rationalized the square root, and then they combine the fractions. We're not going to worry about that. We can talk about it in pre-calc. Okay. But those two values match. Our value, its decimal approximation, matches the decimal approximation of the value on the answer key. So we're going to go with that. Okay. I'm okay with you leaving the answer in this form. Okay. Even though it's not rationalized, even though it's not fully simplified, let's just leave it at that. Okay. If you run into one of these, just compare the answer choices. Yes, sir. Yeah. I mean, if y'all really want me to show you, I can show you. Okay. Let me show you. All right. I'll show you how to do it, just for kids. Okay. So the whole square root thing that I was telling you, you take the square root of the top, you take the square root of the bottom. We don't like to leave square roots in the bottom. So we multiply top and bottom by the square root of 7. Okay? So what happens? 13 times 7, I'm assuming, is 91. Okay? And when you multiply the square root of 7 times the square root of 7, that is 7. Okay? And then the other step to get it to look like what's on the answer key is we need a common denominator. The negative 1 needs to be as over 7. Well, negative 1 as something over 7 would be negative 7 over 7, right? That simplifies to negative 1. So here is where the answer key gets their answer from. Okay. So when you take the square root of a fraction, you take the square root of the top, the square root of the bottom. You can't take the square root of 7 like we can take the square root of 4. So we have to rationalize. We multiply top and bottom by the square root in the denominator. So 13 times 7 is 91. Square root of 7 times square root of 7 is just 7. Because that 7 times 7 is 49, and square root of 49 is 7. Okay? We need a common denominator. This one, negative 1, doesn't have a denominator right now. We need it to have a denominator of 7. So negative 7 over 7 is negative 1. So then they have the same denominator, so we can do that numerators. So if you get that, great. Knock yourself out when you're doing the problems to put it in that form. If not, otherwise, you leave it like that and just compare, type it into your calculator and make sure that it matches. Okay? Let's do one more. Okay, 5x squared plus 10x minus 71 equals 5x. We've got two things to move here. We need that 5x to be on the left side, and we need the 71 to be on the right side. So we've got 5x squared plus 5x. I'm not going to worry about the space right now because I have to factor first. So let's factor out the 5, x squared plus x. Now I'm going to leave the spot, leave space. Okay, complete the square. 1 divided by 2. Well, that doesn't divide evenly, so we leave it. Squared is 1/4. Fractions. Okay, I don't add 1/4 to the other side. I gotta multiply by 5 first. So 5 times 1/4 is 5/4. So I add 5/4 to the right side. So on the left side, we have 5 times x plus 1/2 squared is equal to, let's see here, 71 times 4 is 284 plus 5, so 289 over 4. Okay, 289 over 4. Okay, so we got to divide by 5, but I have a fraction on the other side, so I want y'all to get used to the idea that division is the same as multiplying by the reciprocal. Okay, the reciprocal of 5, reciprocal means you flip it over, so it's the same thing as multiplying both sides by 1/5. That's just going to help me with the fact that I've got a fraction over there. So that's 289 over 20. If that fraction will reduce, we would like to reduce it. It does not. They usually do. Okay. Take the square root. So we've got x plus 1/2 equals plus or minus square root of 289 over the square root of 20. I'm going to go ahead and go through the rationalizing thing while I'm at it. Okay, so rationalize, multiply top and bottom by the square root of 20. So I've got x plus 1/2 equals plus or minus square root of 289 times 2. Thank you. 5,708. That's a big number. Over 20. But guess what? It's going to reduce a lot. All right, I'm going to go ahead and move the 1/2 over. So that's minus 1/2 plus or minus. Let's look at simplifying 5,780. Let's see here. Whoops. It's not divisible by 100. Let's see if it's divisible by... It's not going to be 25, is it? Nope. 49. Nope. 64. I'm looking for a big one here since it's such a big number. 81. No, I doubt it. Nope. 144. No. Anybody having any luck? Did I try 16 already? Nope. 289. Ooh, there we go. 289. Oh wait, something bigger than that though, because 20 is divisible by 4. So, okay, well let's just go with the intermediate step of 289. Okay, 289 is what? 17 squared? Okay, so we'll go with the intermediate step here so I can illustrate something to you guys. All right, so the square root of 289 is 17, and 20 stays under the square root. Okay, now, I know that it reduces further because 20 is divisible by another perfect square. 20 is divisible by 4. So that's okay. So I'm just going to end up multiplying it by 2 because the square root of 4 is 2. And I can reduce the 2 over 20 to 10. I know I'm getting very jumbled here. Okay, so how do we express negative 1/2 as something over 10? Negative 5 over 10 reduces to 1/2. So here is the answer. Whew. I don't know about you, I feel very accomplished after all that. Let me make sure I didn't screw anything up. Nope, we're good. Okay, we're good. Hopefully that all made sense. Mostly. It is a lot. It is a lot. Okay, let's do one more just for kicks and giggles. Let's do 21. Negative 4x squared minus 22x plus 79 equals negative 5x squared minus 5x plus 2. So, ooh, this is nice. If we add 5x squared to both sides. Wait, we already done number 20? No, we haven't done 21. Okay. If we add 5x squared to both sides, negative 4 plus 5 is 1. That's nice. Add 5x. So negative 22 plus 5 is negative 17. And we need to move the 79 over to the other side. And because my a is equal to 1, I'm going to go ahead and leave my space for completing the square. Because I don't have to do the factoring thing. Okay? So, divide by 2. Huh? 289 over 4? Yes. 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 Okay. So, divide by 2. Not evenly divisible, so we square it. Oh, guess what? We just dealt with 17 squared. It was 289. 2 squared is 4. So, plus 289 over 4 on both sides. So we've got x minus 17 over 2 squared on the left side. Let's add negative 77 and 289 over 4. And I know it's going to be a fraction, so I'm going to go ahead and press math, enter. Negative 19 over 4. So we haven't dealt with this with completing the square. A negative over there, but it's just like with the quadratic formula. we continue with our process. We take the square root of both sides. We're taking the square root of a negative number, so that automatically pops out as I. And 19 is not a perfect square, but 4 is. So I'm going to go ahead and write it like this. Make sure, please make sure that it is clear where your division sign is. Is your division sign inside the square root, or is it outside of the square root? So in this case, it's outside. So make sure that on your paper, yours looks like this. The division line, or the fraction line, whatever you want to call it, extends under that I. Okay, make sure it extends under that I. So this one's not bad. Okay, I use this one. I wanted this one because it had the imaginary part to it. We don't have to do all that simplifying and rationalizing and all that stuff. I just wanted to point out that we can also get imaginary solutions from completing the square. We would have gotten the same solution if we had used the quadratic formula on this, but look at, we would have had to simplify a lot with the quadratic formula, because b was negative 17, c is 77, so we would have had to simplify that square root to get it in that form. Okay? Questions? Good? Okay. So I would like for you to try